constant pressure, take note, at constant pressure, the enthalpy change equals the heat released. So pag sinigaan mo yung panggatong, kung ano yung na-release na heat, that is actually the enthalpy or the change in enthalpy. Take note, change in enthalpy is equal to the heat released or heat absorbed. So pag nag-release ng heat, delta H is negative. But it depends on the quantity of wood that has been burned. Naintindihan nyo? Class, naintindihan? Delta H is equal to Q. It can be, yung Q na yon, yun yung na-release na heat. Kaya negative siya during the burning of wood. Naintindihan?
Yes, ma'am.
Now, what actually is enthalpy? It is a thermodynamic property that is the sum. Okay? Take note. That is the sum of the internal energy that is added to the system and the product of its pressure and volume. It's a measure of the system's capacity to release heat and perform non-mechanical work. Take note of the statements. Yung mga statements, tatandaan nyo ha. It can be negated, meaning to say, it can be stated oppositely, especially sa exam ninyo. So, dapat alam nyo kung ano yung mga statements that are not correct and statements that are correct. In equations, enthalpy is denoted by the capital letter H, while a specific enthalpy is lowercase h. But what we will be dealing with is the capital letter H. Okay? Now, the units of enthalpy are joules, calories, or BTUs. It can also be kilojoule per mole. Ang basis natin dito, 1 mole of the substance. Yun yung quantity ng substance mo. 1 mole. Now, BTU means British Thermal Unit. BTU is a unit of heat under the English system. Calories and joules are under the metric and SI system. Okay? Now, enthalpy, which is denoted by the symbol H, equals the internal energy plus the product of the pressure and volume of the system. So, nare-relate din natin yung internal energy sa enthalpy. Okay? Enthalpy. So, enthalpy is actually equal to internal energy denoted by uppercase U plus PV. PV is pressure and volume. Enthalpy is a state function because internal energy, pressure, and volume are also a state function, meaning it depends upon the state of the substance. And in this case, you are going to consider that enthalpy, internal energy, pwede rin yung pressure, pwede rin yung volume, can be taken with what you call the difference, the change. Diba? Mayroong change in enthalpy, delta. Mayroong change in internal energy, delta U. Mayroon dahil tayo tinatawag na change in pressure and volume, delta PV. So they are what you call state function. Now, when a change occurs at constant pressure, then delta H is equal to delta U plus delta PV. Pero pag constant pressure siya, ilalabas natin si pressure kasi constant. Magkakaroon lang ng change ay yung volume. So what will happen to our equation or formula? Magiging internal energy kasi is Q plus W. Remember? The change in internal energy is actually heat plus work. Can you still remember? Huh?
Yes, ma'am.
Pag sinubstitute natin yung delta U dito sa equation Q plus W, then alam nyo naman na yung P delta V is the negative work. So, i-substitute natin dito, negative W. Magka-cancel out yung dalawang W kasi positive W minus W is 0. So, we can deduce that delta H now is equal to the heat at constant pressure. Lagay nyo na sa notes nyo. Delta H is actually the heat at constant pressure. Pag nirelease siya, negative. Pag na-absorb, positive. Okay? So, ni-note nyo na? Noted na ba sa notes nyo?
Ma'am,
Yun yung
pwede mo maulit?
principles na sinasabi ko sa inyo that you should remember. Okay? Delta H is equal to the heat at constant pressure. Ito siya, oh. As we have said doon sa burning of wood, di ba? Constant pressure. Since nag-release ng heat during the burning of firewood, meaning to say your heat there is negative at constant pressure. Alright? The same is true here. The delta H now is equal to the heat released at constant pressure. It depends upon the condition. If it is absorbed, it is positive. If it is released, negative. So that is the change in enthalpy, which is given by the change in internal energy plus the product of the constant pressure times the change in volume. Okay? So we can say that delta H is equal to delta U plus P delta V. Pag given naman ang internal energy tsaka change in volume, pwedeng ito naman na yung gamitin nyo in order to determine delta H. If not, kung given yung heat, automatically yung heat is also your delta H. Depende kung na-release yun o na-absorb. Okay? So may example na tayo dito. The molar enthalpy of fusion for ice at 0 degrees Celsius and a pressure of 1 atmosphere is 6.01 kilojoule. And the molar volumes of ice and water at 0 degrees Celsius are 0.0197 liters and 0.018 liters respectively. Calculate delta H and delta U for the melting of ice at 0 degree Celsius. So, ibig sabihin ng fusion of ice, magmi-melt yung ice. You know very well that the freezing point of water is 0. So, pag nag-0 na yung freezing point, nagiging ice na yung water. Now, of course, the temperature is, the pressure is 1 atmosphere. Atmospheric pressure siya. And the heat absorbed is 6.01 kilojoule. Paano matutunaw yung ice? Of course, mag-absorb siya ng heat from the surroundings, tama? Pag nag-absorb ng heat yung system mo, yung ice, is it positive or negative? Mr. Herrera.
Nag-absorb po, ma'am?
Yes.
Paano po? Positive po.
Positive. Nag-absorb ng heat yung ice. Kaya nga siya magmi-melt. Okay. Now, initially, ang volume ng ice is 0.0197, di ba? Liters. Nang matunaw na siya, naging 0.0018 liters. Liter na lang, respectively. So, ang initial mo is 0.0197, final mo is 0.018. Calculate delta H and delta U for the melting of ice at 0 degrees Celsius. Okay. Do we have to calculate for delta H? Ha? Kailangan ba natin i-calculate yung delta H?
Opo, ma'am.
What did I say about delta H a while ago? Mr. Borbor.
Delta H po is equal po sa constant pressure.
Constant pressure?
Di po.
Huh? What did I say a while ago? Mr. Dupa.
Yung delta H po, ma'am, is equal to heat and constant pressure po, ma'am.
Okay. Kung equal to heat at constant pressure, kailan pa ba nating i-compute sa problem?
No, ma'am.
No, why?
Kasi ma'am, yung ma'am, yung value ng ma'am, delta H is ma'am, yung constant pressure.
Kaya nga,
May given na po ba, ma'am? Parang gano'n.
given. So, anong given? Tignan nyo to ha. Balik tayo. When a change occurs at constant pressure, yung change na yon, yung volume ang mag-change. What will happen to your delta H? Delta H will now be equal to the heat at constant pressure. It depends if it is absorbed or released. Balik tayo sa problem. The molar enthalpy of fusion of ice at constant pressure and 0 degrees Celsius is 6.01. Ang pressure mo, constant 1 atmosphere. 6.01 kilojoules. So, ito na yung delta H natin. Ito na mismo. So, we did not calculate anymore for delta H. Nakuha nyo? Ang ika-calculate na lang natin ay delta U. Delta H is equal to the absorbed heat by the system, yung ice at constant pressure. Now,
Question po, ma'am. So, bali po yung delta H po is 6.01 kilojoules po.
yes,
Okay.
yun na nga mismo. Since it is absorbed, positive siya. Because 6.01 kilojoule of heat is absorbed from the surroundings when 1 mole of ice melts, Q is positive, 6.01 kilojoule, when the process is carried out at constant pressure. Therefore, QP is equal to delta H is equal to 6.01 kilojoule. Naintindihan? Now, to find delta U using the equation, we need to calculate delta PV. Kasi mayroong change in volume, di ba?
Kita niyo na.
So the process is carried out at a constant pressure of 1 atmosphere. So ilalabas natin si pressure
Meron na.
P,
Meron na.
tapos
Nakatingnan
we
ko.
will get the difference in volume, B final
Mat.
minus initial. Okay?
Score
So,
daw, meron na.
your pressure is 1 atmosphere times the change in volume, final minus initial. So,
Nilalabas ko
0.018
lang.
minus 0.0197, we have negative 0.017 or negative 1.7 times 10 to the minus 3 liter atmosphere. Okay? Liter atmosphere ang unit. Kailangan natin siyang i-convert sa joule. So, what is the conversion factor from liter atmosphere to joule? 101.3 joule in 1 liter atmosphere. So, yung delta PV natin is 0.0017 joule. Negative. Okay? Negative. Now, substituting the calculated values of
59.
delta H and P delta V, delta U here is equal to delta H minus P delta
58 ako,
V.
58.
Okay? Because our
Naku, may libre
volume
akong
here is
kaya.
negative. Okay? Meaning to say, from larger to smaller. So, we might as well say that our work is positive. So, if you're going to substitute now in the formula, it will be 6,010 joules Yun yung delta H mo minus delta PV, which is negative 0.0017. So, negative times negative is positive. We can say now that it is equivalent to 6,010 joules also, or 6.01 kilojoule. Because this one is very minimal compared to this. Kaya it is actually equal to delta H. So we can say therefore that Q is equal to delta U is equal to delta H. Alright? It so happened kasi na napakaliit yung volume natin. Change in volume. Okay? Naintindihan? Class, speak up. Anong malabo dyan para ma-explain ko? Ha?
Substitution lang siya ng value, ma'am, no? Ilalagay lang po yung sa formula, yung
Of
value.
course.
Tapos makuha na agad sila. Wala na siyang iba pang parang iba pang iba't ibang pasikot-sikot, parang ganun.
Kaya nga sabi ko sa inyo, very simple ang mga problems na ibibigay ko sa inyo. Ang intindihin nyo yung problem basing on the principles. Ang bear in mind, you bear in mind the principles involved. Gaya niyan, negative or positive ang heat. Okay? Mr. Coronel, may tanong?
Yes po, ma'am. Ma'am, confusion lang po sa formula po. Medyo, yung sa pag-change, ma'am, ng delta heat to yung kanina, yung delta U po ata yun.
Bakit? Anong ano doon?
Ano po ba yun, ma'am? Nakadepende po ba sa problem if mag-change po yung mga delta po?
Yes, pag given kapag may mga initial and final condition, that's the time that you are going to consider delta. Okay? Naintindihan?
Thank you po.
Bakit negative ito? You might be asking, bakit negative yung PV? Kasi 'di ba, work is equal to negative P delta B. Kung yung positive mo dito, 'di ba positive 'yan? Ito positive. Magiging negative siya because of the pressure which is done against. 'Di ba? W is equal to negative P external delta V, remember? Sa termo part 1. Okay, kaya naging negative ito. Alright? And the reason why also is that yung volume kasi natin, the change in volume is from larger to smaller one. Larger to smaller one. So magiging negative work siya. Kaya naging negative dito. Ito. Ayan. Got it?
Ma'am, saan po nakuha yung negative 1.7 times tsaka yung 101.3 po?
Conversion factor ito. Binigay ko ito sa inyo nung term 1. Conversion factor ito. 101.3 joule is equivalent to 1 liter atmosphere.
Yung po ma'am, yung negative 1.7.
Ito, the difference between these two, ayan, yung volume mo, delta V. Pressure mo yung 1 atmosphere, ito, yan, P delta V. Okay na?
Opo, ma'am.
Okay, another example. Hydrogen peroxide decomposes, sa chemical reaction naman to. Hydrogen peroxide decomposes according to the following thermochemical reaction. Okay? Hydrogen peroxide yields water plus 1/2 mole of oxygen gas. Now, the delta H of the reaction is negative 98.2 kilojoule. Calculate the change in enthalpy when 1 gram of hydrogen peroxide decomposes. Okay. You must remember, class, that enthalpy or change in enthalpy is a molar thermodynamic property. Pag sinabing molar, we base on per mole. Halimbawa ito, negative 98.2 kilojoule of enthalpy. This is considered to be per mole. Now, tinatanong ngayon, per mole of hydrogen peroxide. Tinatanong ngayon kung 1 gram. Paano pag 1 gram? Hindi tayo gagamit ng formula dito. What we will be using is a dimensional analysis. Paano na kukunin yung again, paano natin kukunin or how can we consider taking delta H given the mass of the substance or hydrogen peroxide? Walang given na number of mole, pero we are given delta H. Okay, before that, ang tanong ko, how do you determine the number of moles of a substance? Ganun na lang. Yun na lang ang tanong ko.
Ma'am, ano po ulit kasi, ma'am?
How do you determine the number of moles of a substance?
Ano po, mass divided by molar mass.
Okay, mass over molar mass or molecular weight. Tandaan nyo palagi yun, ha? When you're asked to determine the number of moles, dapat mayroong mass and then you can get the equivalent molecular mass doon sa periodic table ninyo. Okay? So, hindi tayo gagamit dito ng formula. Yun lang. Yung number of mole, yun lang. Pero sa enthalpy, there's no need. Kasi gagamitin natin dito is just conversion factor and what you call dimensional analysis. So this sort of problem is solved by using a table to look up the change of enthalpy unless it is given. So given na siya, ito na siya, negative 98.2 kilojoule. The thermochemical equation tells us that delta H for the decomposition of 1 mole of water or hydrogen peroxide is negative 98.2 kilojoule. So this relationship can be used as a conversion factor. Ito yung gagamitin natin conversion factor sa dimensional analysis. Once the change in enthalpy is known, the number of moles of the relevant compound is to be determined to calculate for the value of enthalpy change. So using your periodic table to add up the masses of hydrogen and oxygen atoms in hydrogen peroxide, the molecular mass of hydrogen peroxide is 34 grams per mole. Okay? 34 grams per mole. So using these values, makukuha na natin yung delta H for 1 gram of hydrogen peroxide. So start with 1 gram hydrogen peroxide times the molecular mass of hydrogen peroxide, ilagay nyo sa baba, 34 grams per mole multiplied by negative 98.2 kilojoule per mole of H2O2. And by that, you will be able to get delta H equals negative 2.89 kilojoule. Nasundan nyo ba? Nasundan niyo ba yung ano? How delta H was determined making use of dimensional analysis? Ha? Sundan ba? Sabihin niyo kung hindi. Para ipapakita ko sa inyo. Ha?
Medyo lang po.
By dimensional analysis. Okay, we start with 1 gram of H2O2. Okay, dimensional analysis lang to, class. Kita niyo ba, class?
Atras ka daw po konti, ma'am. Yan naman, okay naman.
Okay naman.
Ayan, no, di ba? 1 gram, ito siya. Ayun, 1 gram. Ayan. 1 gram H2O2 multiplied by the molecular mass of H2O2. Pero baliktarin nyo, dapat nasa baba yung grams para mag-cancel out yung grams dito. So, ang naiwan dito ay mole. H2O2. Now, para makuha natin yung total change in internal energy of the dissolution, or what you call the decomposition of H2O2, kukunin natin ngayon yung change in enthalpy per mole. Kasi diba sabi ko sa inyo, ang enthalpy ay a molar thermodynamic property, meaning nakadepende sa number of mole ng substance. So, negative 98.2 kilojoule per mole H2O2. So, ito na siya. Negative 2.89 kilojoule ang sagot ninyo. O, naintindihan? Dimensional analysis yan, ha? Hindi tayo gumamit ng formula. Tinatanong lang kasi yung delta H ng 1 gram of H2O2 na mag-decompose into what? Sa ano natin? Sa reaction natin kanina. Ayan, no? H2O2 to water and oxygen gas. O, naintindihan na? Clear?
Ma'am, bali po, ano po, kinross multiply po yung 34 sa negative 98.2.
Cross multiply. Wala tayong cross multiply dito.
Ay, wala po.
Dire-diretso yan, no? Dire-diretso yan. Okay? Dimensional analysis nga, di ba marunong na kayong gumamit ng dimensional analysis? Yung conversion. Okay? O, naintindihan na.
Opo, ma'am.
How about the others? Naintindihan nyo? Class, sumagot naman kayo kung naintindihan nyo. Yes, Mr. Doringo.
Ma'am, pwede pakiulit po. Medyo
Galit.
naglalag po ako eh. Pasensya na po, ma'am.
Anong uulitin ko? Yung dimensional
Yung
analysis.
ano na, sa may second part na po. Yung parang may yung
Hindi na kita marinig. O, screenshot nyo na lang.
ma'am, narinig po ba ako?
Hmm. Screenshot nyo na lang to para mas maintindihan nyo.
Okay po, ma'am. Sige po.
Ayan. Parang yung ginagawa natin pag nagko-convert tayo, ganyan din yan. Wala tayong ginamit dito na formula. Kasi tinatanong lang yung change in enthalpy of 1 gram of H2O2 given the value of enthalpy of H2O2 which is negative 98.2 per mole. 1 gram yung tinatanong. So ito na, introduce natin yung 1 gram dito, but you have to make use of the molecular mass of H2O2. Okay? Let's proceed. Calorimetry na tayo. This is one of your simulation. Nakaka-publish ko pa lang. So what is calorimetry? Have you heard the term calorimetry already? Sa physics nyo nung high school? Class?
Yes po.
Okay. So calorimetry is a means, okay, to measure heat transfer during chemical or physical processes. Sa chemical, of course, chemical reactions are involved. Sa physical processes, that means to say, there's no chemical change that will happen, but there shall be changes with respect to the temperature that will render the transfer of heat absorbed or released by the system. Since it is hard to directly measure heat transfer is measured in terms of temperature changes. So how can we do that? By making use of calorimetric process. In an actual calorimetric experiment, the heat lost or gained in the reaction is related to the temperature change of the calorimeter. Okay? Meaning to say, pwedeng yung calorimeter mo ang nag-absorb ng heat which is released by the reaction. So, ang mangyayari nito, mag-absorb si calorimeter, positive siya. Yung reaction mo, negative. Yung reaction, nag-release ng heat, kaya negative siya. But they have the same value. Yun nga lang, ni-release, tapos inabsorb ng isa. Ni-release ni reaction, inabsorb ni calorimeter yung heat. Pwede namang si calorimeter ang nag-release ng heat, inabsorb naman ni reaction. Okay? As shown in the equation, the amount of heat released or absorbed by the reaction is exactly equal to the amount of heat absorbed or released by the calorimeter, except mag-change ang sign nilang dalawa. Diba? Kung absorb, positive. Kung release, negative. Okay? Remember that. Heat flow and temperature. when heat flows into an object, it makes sense that its temperature increases. Tama naman, di ba? How much the object increases in temperature is dependent on its heat capacity. So, what did we say about heat capacity before in term of part 1? Still remember yung specific heat capacity? Meron pa tayong table for that for a specific substance like ice, water, liquid water, gases such as air. Meron tayo niyan, di ba? Pinakita ko pa yung table sa inyo. Okay. So what is heat capacity? The heat capacity is the quantity of heat required to raise the temperature of something 1 Kelvin or 1 degree Celsius. 1 Kelvin or 1 degree Celsius. Saglit lang, class. Okay. So the heat capacity is the quantity of heat required to raise the temperature of something, any substance, 1 Kelvin or 1 degree Celsius. So here, the formula is Q is equal to C delta T, where delta T is equal to the final temperature minus the initial temperature. TF is the final, of course, and TI is the initial temperature. Now, there is also what you call molar heat capacity, C sub N. So the molar heat capacity, C sub N, is the quantity of heat to raise the temperature of 1 mole of a substance 1 Kelvin or 1 degree Celsius. Dito, mass. Okay? Pag sinabing specific heat capacity, yung mass ang kinoconsider natin. Pag molar heat capacity naman, yung number of mole. Okay? But we are more, we will be using more of this one. Sa mass tayo, ha? So N is the number of moles of the substance. Cn is the molar heat capacity of the substance, which is also found in the table. And of course, delta T is the TF minus TI. We have the final minus the initial temperature. There are two main types of calorimeters. We have the bomb calorimeter. So ito yung ano nyo, simulation ninyo. Calorimeters, making use of bomb calorimeters. Now, for bomb calorimeter, it is the one that maintains constant volume during the process. So we call it constant volume calorimetry. So meaning to say, the volume is constant. Na hindi nag-change yung volume. Now, for constant pressure calorimeter, which is, an example is a coffee cup calorimeter, the calorimeter maintains constant pressure, but volume changes may occur. Meaning to say, pwedeng mag-change din ang volume. But specifically for bomb calorimeter, constant ang volume niya. Constant. Okay? Okay, so in this case, for bomb calorimeters, if it maintains constant volume during the reaction, no PV work is done during the process. Okay? No PV work is done during the process. So, if there is no PV work, why did we say that at constant volume there is no PV work? Judging from the formula. Bakit walang PV work pag constant ang volume? Ha? Bakit walang PV work pag constant ang volume? Miss Magnaye?
Pa-audit po ng
Yeah,
PV
why
work po.
is why is it that no work or PV work is done if we have constant volume?
Ano po, parang sa base po siya ata dun sa gas law po.
Ha?
Kind of confused pa rin po. Nagsisink it pa rin po yung mga lessons sa akin.
Hindi pa rin nagsisink in.
Opo, yung process pa din po.
Ma'am,
Okay, bakit? Oh, sige, Mr. Estribor, bumawi ka. Mag-recite ka ng mag-recite
Okay.
para makabawi ka.
ma'am, estoma po, ma'am.
Ha?
Estoma po.
Ay, mo ba ito?
Opo, ma'am.
Pati ba kanina, ikaw yung nag-recite, hindi Estribor?
Opo, ma'am.
Kanina?
Opo, ma'am.
Si Mr. Estribor yung nalagyan ko ng points. Kasi ang nakita ko lang is est. Nakita ko lang kasi is est.
Ako po yung sa pinakauna po.
Ang
Pinakauna niyo pong question.
Ma'am, ma'am, yung nag-recite kanina yung sa mas over,
Oh, yun nga. Kasi
Opo.
plus 2 ako kay Mr. Estribor. Yung pala, ikaw yung isa.
Opo, ma'am.
O ngayon, anong sagot?
Kaya po ba walang, kaya po ba walang PV work kasi po walang expansion kasi constant volume?
So, anong mangyayari pag constant volume? No work. Bakit no work?
Opo.
Kasi constant volume.
Opo, ma'am. Wala pong expansion. Tama po ba?
So, how do you relate it doon sa formula ng work? Diba work is negative P delta V? P external. O, kung pareho yung volume, BF minus BI is 0. Pressure times 0 is 0. Therefore, work is 0. Okay? Although tama yung sinabi mo, Mr. Estomo, kaya lang gusto ko sana mas specific yung sagot. Anyway, binigyan naman kita ng points.
Thank you po, ma'am.
Because the volume is constant, no PV work is done during the process. Therefore, ang i-measure natin is delta U of the reaction. Naintindihan? Naintindihan? And what is that delta U? Paano nga mo ngayon i-measure yung delta U? That is actually the heat released or absorbed. Balikan natin yung formula. Ito, di ba? Oops. Ito. Parang sa delta H din. If this is 0, nakita nyo yung formula? Delta U plus delta PV, delta U plus delta PV is equal to Q. Diba? Remember, Remember, delta U is equal to Q plus W. Originally, di ba? Class. Naalala nyo, delta U is equal to Q plus W. Balik tayo ulit. Ayan. Therefore, kung W is 0, therefore, we can say that delta U is equal to Q. Nakuha nyo yung logic? Ha? Kasi ang working equation natin is delta U is equal to Q plus W. W is PV work. Since walang PV work, therefore, delta U is equal to Q. Got it? Naintindihan?
Yes, ma'am.
Okay, so ito na yun, oh. Recall that delta U, nire-review ko lang kayo kung may natandaan kayo sa thermo part 1 eh. So recall that delta U is equal to Q plus W, and W is equal to negative P pressure external times change in volume. If delta V is 0, then work done is 0. Therefore, we can say now that delta U is equal to Q plus 0. Therefore, change in internal energy is actually equivalent to the heat at constant volume. Sa bomb calorimeter. Diba, ang bomb calorimeter is we have to consider constant volume. Okay? So, paano mo kukunin ngayon yung QV? That is making use of the formula MC delta T. So, yun na yung internal energy mo rin, which is equivalent to heat at constant volume. You got it? Naintindihan? Ha?
Ma'am, pwede ba pa ulit, ma'am?
Di ba, yung sabi mo nga yung W is 0. Kasi constant volume tayo sa bomb calorimeter. So, pag 0 ang W, so yung formula mo na lang is delta U equals Q, which is the heat at constant volume. How are you going to get the value of Q, which is also delta U? Gagamit ka ngayon ng QV is equal to MC delta T. Okay? I-incorporate mo dito yung mass ng substance. Alright?
Okay po, ma'am.
Okay. So this is a schematic diagram of bomb calorimeter. We have a vessel. Okay, depende kung yung vessel is made up of any metal. Pwedeng aluminum, pwedeng iron, whatever metal. So, meron tayong cavity dito in which dito nangyayari yung reaction which is being heated. Meron tayong temperature, thermometer to monitor the temperature change. So, they are used in reactions. Bomb calorimeters are used in reactions where one or more of the reactants is a gas. The bomb is made of rigid materials such as steel and includes a cavity for reactants surrounded by a water bath. C, so apply natin ito, Q is equal to C delta T, where C is the heat capacity of the whole calorimeter, water, and steel. So kukunin natin separately yung specific heat ng water, yung container mo, at saka kung ano man yung isa pang reactant mo dito. Okay? Okay, so example natin. 0.05 mole of hydrogen gas and 0.025 mole of oxygen gas react to produce water according to the reaction. 2 moles of hydrogen gas plus 1 mole of oxygen gas gives you 2 moles of water. Now, the heat capacity of the calorimeter, hindi na mention kung anong type of material, pero ibinigay naman yung specific heat. is 90.6 kilojoule per degree Celsius. And the initial temperature is 25 degrees Celsius. Now the reaction is ignited and the temperature increases to 25.155 degrees Celsius. So calculate the heat for this reaction. We assume here, mag-assume tayo ng 1 mass, 1 gram mass. Mag-assume tayo dito ng 1 gram mass of the substance. Ha? Now, we get the change in temperature from initial to final. So TF minus TI, 25.155 minus 25 is equal to 0.155 degrees Celsius. Now, nakita nyo, napakaliit yung difference in temperature, di ba? Napakaliit yung difference in temperature, 0.155 lang. So, substitute mo na dito, the heat now is equal to C delta T, 90.6 divided, which is the specific heat, times the change in temperature, you have 14.0 kilojoules. Saglit lang, class. Okay, so, saan na tayo? May tumawag kasi class, sorry. Oh, so yun, 14 kilojoule ang sagot dito. So, by this, was heat absorbed or released by the reaction? Is the reaction endo or exo? So, ano sa tingin nyo? Yung heat na 14 kilojoule, is it absorbed or released by the reaction?
Release po ba, ma'am?
Ha?
Release po.
Positive. Ang kinuha natin dito is
Okay po, ma'am. Gets na po.
the heat absorbed by calorimeter. Kasi yung reaction nag-release ng heat. Nag-release ng heat kasi nga pinainitan mo, di ba? Para makapag-produce ka ng water, ng tubig. So meaning to say, when the reaction is heated, the reaction released heat to the calorimeter. Nag-absorb si calorimeter ng heat, so positive siya. 14 kilojoule. Okay? Kasi tignan nyo yung temperature, oh. Tumaas siya 25. Although very minimal yung temperature rise, 0.155 lang. So meaning to say, the temperature of the calorimeter is increased. Heat was released by the reaction and absorbed by the calorimeter. So the reaction is exothermic. Kasi si reaction nag-release ng heat na absorb ni calorimeter. Kaya Q calorimeter is equal to the negative heat of reaction. Naintindihan, class?
Yes po, ma'am.
So, the reaction is exo. Kasi yung reaction mo, nag-release ng heat. Yan yung point. I-note nyo na yan sa mga ano nyo, sa notebook nyo. Para at least nare-remind kayo, ha? Okay. Punta naman tayo sa constant pressure calorimetry. Anong oras ba tayo?
130.
Hanggang 1:30 lang, di ba?
Yes po, ma'am.
May subject ba kayo? Susunod dito?
Opo, mat po. Pero 3 p.m. pa po.
3 p.m. pa. So, pwede ba nating ituloy? Class? Pwede ba nating ituloy? Tapusin lang natin ito. Kahit hanggang sa ano lang. Hanggang dito lang sa calorimetry para magawa nyo yung simulation. Ha? Extend tayo, ha?
Pwede ma'am habang nag-lesson ka, sagutan ko po yung isa pang simulation ko.
Hindi, makinig ka muna, Mr. Marquez.
Okay, ma'am.
Pag hindi mo narinig, okay. So, sa iba ba, okay lang? Wala kayong klase sa ibang subject? Meron bang irregular dyan? Okay. So, I'm asking permission from you so we can extend. Naghabol tayo ng oras, class. Ako mag-overtime. Are you amenable to that? Yes, Mr. Jose?
Ma'am, pwede po abulin yung activity kanina, ma'am. Kasi po nawalan po ako internet kanina po.
Nakapag-umpisa ka ba?
Hindi po, ma'am. Hindi po kasi ako nakapasok ng maaga po.
Sino pa yung isa? Si Nicasio ba? Andiyan ba si Nicasio? Para magsabay na kayo. Mamaya, tapusin ko lang tong lesson, okay?
Po, ma'am. Thank you po.
Nakita mo ba yung nakapresent na given na problem sa table? Mr. Jose?
Hindi po, ma'am.
Okay, after na lang nito. I-discuss ko muna yung constant pressure para makapag-simulate kayo sa calorimetry. Okay.
Okay po.
Recall that delta H is the heat at constant pressure. Remember kanina? So we can say now that delta H is equal to delta U plus P delta V. That is actually the heat at constant pressure. So meaning to say, pag constant pressure calorimetry, if the heat is given, you need not solve delta H anymore. Sa constant volume naman, if the heat is given, you need not solve for delta U because delta U is also equal to the heat at constant volume. Ano yun? Si Mr. Blase, ano yung sinabi? Nagpaalam ba? Therefore, constant pressure calorimeters measure delta H directly. Constant volume measures delta U directly. You see the difference? Sa constant volume calorimetry, sa bomb calorimeters, na may measure ka agad ang delta U, which is equivalent to the heat at constant volume. Dito naman, sa constant pressure calorimetry, example natin is coffee cup calorimeter, na may measure ka agad yung delta H. Okay? So this is an example of constant pressure calorimeter. Meron tayong thermometer sa loob and stirrer para maging uniform yung temperature. Tapos it is insulated para hindi maka-escape ang heat. Alright? So measuring heat transfers during chemical reaction, making use of a coffee cup calorimeter. Where M, ang gagamitin natin dito is delta H of reaction is equal to the heat of the reaction, which is the negative heat released by the calorimeter, is equal to negative MCS delta T. Therefore, we can say that the heat of the reaction is equal to negative MCS delta T. Ito naman yung case dito sa constant pressure. So, M is the mass of the water kasi merong water dito. The reaction happens here inside na may tubig din. CS is the specific heat capacity of water or solution. And delta T is the temperature change. So ganun din yung formula na gagamitin nyo. Just like a volume-based calorimeter. So meron na tayong example dito. A student built a coffee cup calorimeter using 100 milliliters of water. Dinagdagan ng 4.95 grams of solid potassium hydroxide. Okay? So what will happen? As the KOH dissolved into solution, the temperature of the solution increased from 23 degrees Celsius to 34.5 degrees Celsius. Calculate delta H of the reaction. You may assume the density of water is 1 gram per ml and its specific gravity, specific heat capacity is 4.184 joule per gram degree Celsius. Okay? So, hahanapin natin dito yung delta H ng reaction. So, how do we find it? Of course, we solve for Q. Diba? Before we start with the calculations, let's think about where we are going and the concepts involved. What is the reaction happening? It is the dissolution of potassium hydroxide in water. Dinidissolve natin yung potassium hydroxide sa tubig inside the calorimeter. Second, what is the temperature of the solution in the calorimeter? Okay? The temperature of the solution in the calorimeter increased, so heat was absorbed by the solution in the calorimeter. Knowing this, is the dissolution reaction happening in the calorimeter releasing or absorbing heat? Yun yung sasagutin natin. The reaction is releasing heat again. Kasi ang potassium hydroxide is actually a base. Parang sodium hydroxide, pag dinagdagan mo ng tubig, umiinit talaga. So the reaction is releasing heat and the calorimeter absorbs it. Inabsorb din ng calorimeter. Therefore, the heat absorbed by the calorimeter is equal to MCS delta T, or what we call now the negative heat of reaction. So we apply the formula. Q of the calorimeter is equal to MC delta T. Na-absorb niya, so positive, MCS, T final minus T initial. Pero kailangan nating malaman yung mass ng solution. That is, mass ng tubig at saka mass ng potassium hydroxide. Alam mo na yung mass ng potassium hydroxide to be 4.95 grams. Now, determine the mass of the water making use of the volume of the water and the density of water. The density of water actually is 1 gram per ml. Diba? 1 gram per ml. Multiply by 100. So the mass of water is 100 grams plus 4.95. The total mass is 104.95 grams. Then, substitute na natin sa formula. Ayan na. Okay? Q of calorimeter is 104.95 grams times the specific heat, 4.184 joule per gram degree Celsius, times change in temperature. So we have 1,049.8 joules. Yun na yung heat which is actually the change in enthalpy. Okay? Positive siya kasi inabsorb ni calorimeter. Nag-release ng heat si reaction. Okay? So, ibig sabihin, class, yung 5.05 kilojoule, that is the release heat per mole of potassium hydroxide. Okay? Sorry. The 5.05 kilojoule, which is the heat released by the reaction, that is used in dissolving 4.95 grams of potassium hydroxide. But, diba per mole ang reaction, delta H reaction per mole, kasi molar thermodynamic property siya. Okay. So, gagamit tayo ngayon ng molecular mass para maging per mole yung enthalpy change natin. Yung change in enthalpy of the solution. Okay? So, by getting the molecular mass of potassium hydroxide from your periodic table, we get it to be 56.11 gram per mole. So, ito na yung gagamitin natin para yung unit natin sa enthalpy will be kilojoule per mole. Kasi molar thermodynamic property siya. So, 56.11 gram per mole times negative 5.05 kilojoule per 495 grams of potassium hydroxide, you will get negative 57.2 kilojoule per mole of potassium hydroxide, which is the delta H of the solution. Okay? Ayun. Naintindihan nyo? Class?
Yes po, ma'am.
Okay. So, sundan nyo lang, class, itong yung pagkakasolve ng problem. Just try to read it. I-solve nyo siya without looking at the solution para maintindihan nyo. Ha? So, we stop at slide number 31.